Right. Let's try to discuss some MCQs. Right. This question was given in 2001 MCQ paper. Let's write the heading as 2001 AL MCQ paper. Question number 21. Question number 21. Let's write the question. The equivalent resistance. Please write the question with me. The equivalent resistance between X and Y. Between X and Y. The equivalent resistance between X and Y in the network. Simplest meaning in the circuit. Network of the resistances. Network of the resistances shown is right. So they have given us a circuit. We should find the equivalent resistance between X and Y. Right. This is the point X. There is a resistor here. There is another resistor. After that, there is another resistor. This is Y. So if the circuit is given like this, you will be very happy. But they have given another two resistors like this. Capital R, simple R. This is capital R ohm. And they have connected another resistance. That's it. Okay. Draw the figure. I'll give you the 5 answers. Simple R, capital R, 3 times capital R. Fourth answer. 2 capital R plus simple R. Fifth answer. 4 capital R plus simple R. Write the question. Check whether you can understand it. The point here, look at board. You just want to name these points as A, B, C, D, right? So once you mark them, look at board. Stop writing, right? This is all these are wires, so you can bend the wires as you wish. All of these are wires, so you can bend them as you wish, right? So if I draw the circuit like this, right? Look at board. I'm going to mark some points. Look at board carefully, right? So actually, this is the point X. This is the point Y. They ask us to find the resistance between X and Y. This is X, right? This is Y. Look at board. So sometimes you will not see the circuit like this, but this is the correct circuit. Right now, I'll mark A, B, C, D points. A, B, C, D points. So this is A, this is B, this is C, this is D. And now, what is the resistance between A and C here? Resistance between A and C, capital R. Am I right? Can you see it? Resistance between the points A and C, capital R. A resistor of capital R ohm connected in between A and C. Similarly, another resistor capital R connected to B and D. Am I right? Can you see it? Another resistor connected, another resistor of capital R connected in between B and D. There is another resistor capital R. This capital R connected in between A and B. Am I right? So this is A, this is B. There is a resistor of capital R in between A and B. Clear? C, D. If you consider the points C and D, what is the resistance in between C and D? That is also capital R. Clear? The resistance between C and D, C and D, capital R. Now, what is this circuit here? What is this circuit? R divided by R is 1. R divided by R is 1. So it is R1 over R2 equals R3 over R4. So what is this? This is a balanced Wheatstone bridge. There is one more resistor. What is that resistor here? That's the resistor of simple R in between B and C. There is a resistor between B and C. So as this is a balanced Wheatstone bridge, no current flows in the BC branch. Am I right? So when no current flows through a branch, we can forget that branch. Put it here. Star point and right. The above circuit is equivalent. Star point and right. The above circuit is equivalent to the following circuit. The above circuit is equivalent to the following circuit. Right, draw it. Think and draw. Think and draw. The above circuit is equivalent to the following circuit. Draw this circuit here, quick. Below the figure, please write. Below the figure, please write. This is a balanced Wheaton bridge. This is a balanced Wheaton bridge. This is a balanced Wheaton bridge. Therefore, no current flows through the BC branch. This is a balanced Wheaton bridge. Therefore, no current flows through the BC branch. Start with and write. If there is a branch where there is no current, if there is a branch where there is no current, if there is a branch where there is no current, comma, that branch can be removed from the circuit. If there is a branch where there is no current, comma, that branch can be removed from the circuit. That branch can be removed from the circuit. That branch can be removed from the circuit. Okay, dear? Therefore, the above circuit is equivalent to the following circuit. Therefore, the above circuit is equivalent to the following circuit. The above circuit is equivalent to the following circuit. So, no current flows in the BC branch. Let me remove it. So, I can just erase it, but you have to draw a new figure. You have to draw a new figure. Start. Draw it. Right. Now, how these two resistors connected here? How they are connected here? They are connected in series. If they are connected in series, what is the equivalent resistance? R plus R, 2R. How these two resistors connected here? They are also connected in series. Therefore, what is their equivalent resistance? R plus R, 2R. Please mark them here. Mark them. Okay. If two resistors connected in series, two or more resistors connected in series, equivalent resistance is the summation. So just add it. So I can write a single resistor in between A and D, right? So this equivalent resistance is R plus R, so that is 2R. Similarly, instead of these two resistors, I can draw a single resistor. I can draw single resistor like this. Right? They are connected in series. Therefore, the equivalent resistance is the summation. As they are connected in series, equivalent resistance is summation. Draw this one also. In the exam years, we don't draw any circuits like this, but now we are learning. Now we learn how to answer this question. Therefore, draw all these figures with. So when two resistors connected in parallel, now they are connected in parallel. What is the equivalent resistance here? Equivalent resistance, or you can say Rxy. Now the two resistors equal, 2R equal. When two equal resistors are connected in parallel, equivalent resistance is one of the resistors divided by 2. Do you remember that theory? When two equal resistors, this is 2R, this is also 2R. When two equal resistors are connected in parallel, equivalent resistance is the one of the resistance divided by 2, half, right? So half of one resistor. That's the method. So half one of the resistors 2R, they are equal. 2 and 2 cancelled out. Therefore, the equivalent resistance is R. So it means the second answer is the correct one. Complete here. That's it. So if this question is given in the exam, you don't do this kind of thing. This is not the way to answer the question, right? Look at what here. We don't draw even a single circuit in the exam. Not even a single figure is drawn. So you should identify this is the Wheaton bridge. R divided by R is 1. R divided by R is 1. Therefore, this is a balanced Wheaton bridge. Okay? So R over R is 1. R over R is 1. As this is a balanced Wheaton bridge, no current flows in the BC branch. Therefore, we can erase BC branch. Once the BC branch is erased, R plus R is 2R. R plus R is 2R. 2R parallel to R. When two equal resistors connected in parallel, equivalent resistance is the one of the resistors divided by 2, or half into one resistance. So 2R, 2R parallel, therefore the equivalent resistance is 2R divided by 2. 2 and 2 cancelled out, answer is R. So it is a 3-4 seconds MCQ. No need to draw any figures. Is the method clear here? R divided by R is 1. This R divided by this R is 1. So it means it's a R1 over R2 equal R3 over R4. It's a balanced Wheaton bridge. Therefore, no current flows in BC branch. So just remove this resistor. No current flows in the branch, meaning you should remove that resistor. After that, R plus R2R, R plus R2R, 2R, 2R connected in parallel. Therefore, the equivalent resistance is 2R divided by 2. That's it. Is the method clear? So that's how you want to solve this problem in the exam. Now let's try to another question. This question is given as question number 45. So please write Q45. Q45. Right. Under that, please write. Consider the following two circuit diagrams. Consider the following two circuit diagrams. Consider the following two circuit diagrams. Full stop. They have given something like this. V1 and V2. Look at both and right. Look at both and right. V1 and V2 are voltmeter readings. V1 and V2 are voltmeter readings. V1 and V2 are voltmeter readings, and look at both. I1 and I2. I1 and I2 are ammeter readings. I1 and I2 are ammeter readings. V1 and V2 are voltmeter readings. I1 and I2 are ammeter readings. Okay, dear? Full stop. If the voltmeter and ammeter are ideal, if the voltmeter and ammeter are ideal, if the voltmeter and ammeter are ideal, and the internal resistance of the cell is negligible, and the internal resistance of the cell is negligible, and the internal resistance of the cell is negligible, which of the following is true? And if the internal resistance of the cell is negligible, which of the following is true? They have given 5 relationships. We have to find the correct one. Which of the following is true? Right. Look at what this. voltmeter V1. It is connected to a resistor like this. That resistance is R. There is a battery like this. There is an ammeter. Ammeter is ideal. Ammeter reading is I1. So this is the first circuit that they have given us. EMF of the battery is E volt. Draw this figure here with. They have given two such circuits. We will consider one by one. Okay, draw it first. Draw this one first. So actually we are trying to be familiar with the questions here. That's why I'm giving huge description. Even I have discussed an MCQ, I give you a huge description because I want you to be familiar with the questions. You must be familiar. You must, once you look at the figure, you should this is what they have asked. Once you have looked, okay, we have done this. I know it. That feeling should come to you. Now voltmeter is ideal. What does it mean, dear? Voltmeter is ideal means internal resistance of the voltmeter is infinite. That is the first fact. Voltmeter is ideal means internal resistance of the voltmeter infinity. The second thing, voltmeter ideal mean no current flows through it. No current flows through the voltmeter. From this side no current, from the other side no current. If the current ammeter reading is the current flows through the ammeter. So current flows through the ammeter is I1, therefore ammeter reading is I1. This I1 current reaches to here. If this is the normal voltmeter, part of this I1 current will flow through the voltmeter. If it is a normal voltmeter, part of this I1 current will flow through the voltmeter. But this is an ideal voltmeter, therefore no current flows through the voltmeter. Got it here? So, the entire I1 current will flow through this resistor capital R and comes back to the battery like this. Can you understand here? Please mark the currents and mark the voltmeter, internal resistance of the voltmeter is infinity. What is the other thing? Wait, one more thing. I forgot one more thing. It is saying ammeter is ideal. What does it mean here? Internal resistance of the ammeter is 0. Ammeter is ideal mean internal resistance of the ammeter is 0. Okay? Complete. Right. How do we find the current here? To find the current, we should apply Kirchhoff's law. Am I right here? Actually, for this circuit, no need to apply Kirchhoff's law. Why? There is only one resistor, one battery. Then we can apply Lamai Ohm's law. Is it? V equals IR. Voltage. The battery voltage is E. Current is I1, resistance is R. If I take R to this side, E divided by R is I1. According to the equation number 1, ammeter reading I1 is voltage of the battery divided by the resistance. It is simple Ohm's law. But please remember that we can apply the simple Ohm's law when the ammeter is ideal. Now ammeter resistance is 0. If the resistance of the ammeter is not 0, then you should apply Kirchhoff's law. Can you understand? If the ammeter has a resistance, if ammeter and voltmeter are not ideal, then you can't apply Ohm's law. Then you should apply Kirchhoff's law. Okay? There are some questions, there are past paper questions where the voltmeter and ammeter are not ideal. When we discuss more questions, more past paper questions, you will find the circuits when the voltmeter and ammeter are not ideal. Now they are ideal. Right? Write this down. Right. Then what is voltmeter reading here? Voltmeter reading. Voltmeter reading is the potential. Look at volt. Difference. Potential difference across capital R resistance. I know this is MCQ, but I am not doing an exam here. I am doing a paper discussion. As this is a discussion, I write all the things. I'll explain everything, right? The voltmeter is connected to the resistor capital R. The voltmeter is connected to the resistor capital R. Therefore, voltmeter reading means the potential difference across the resistor capital R. Right? So, what is the potential difference across the resistor capital R here? V equals IR. It means I1 into R. V equals IR. What is I1? What is I1 here? E over R. I1 is E over R into R. Now what will happen? R and R cancel. Now voltmeter reading is E. So this is the second equation. Wait a minute. They have said voltmeter reading is V1. What they have said here? They have said voltmeter reading V1. So it means voltmeter reading is V1. V1 is equal to capital E. Okay. Ammeter reading is I1. I1 equals to E over R. Voltmeter reading is V1. V1 equals to capital E. Capital E is the EMF of the battery, or the potential difference between positive and negative terminal of the battery. Okay. Complete them all here. After that, let's go to the second circuit. First, you complete them. Right now, let's consider the second circuit. Let's consider the second circuit. Let me draw it. So we have completed everything related to the first circuit. Now we are trying for the second circuit. Right, let me draw it. Look at both. The second circuit, there are two resistors. Here we had only one. So here there are two resistors. Like this. The two resistors are connected to the same battery. The two resistors connected to the same battery. EMF, the voltage of the battery is E volt. Right? Like this. And they have connected an ammeter also. Here the ammeter reading is I2. Ammeter reading is I2. A voltmeter is connected here. The voltmeter is connected here. It's an ideal voltmeter. Its reading is given as V2. V2 is the voltmeter reading. Draw it here. Draw the second circuit. Actually, here in this question, we are going to find the relationship between I1, I2 and V1, V2. We are going to find the relationship between I1, I2 and V1, V2. Draw it. For this circuit, look at the first circuit here. The voltmeter reading is exactly equal to EMF of the battery. Why? The voltmeter is connected to the negative terminal of the battery, and voltmeter is connected to the positive terminal of the battery. The resistance of the ammeter is 0. Resistance of the ammeter is 0 means the voltmeter directly connected to the battery. As the voltmeter is directly connected to the battery, the voltmeter reading is the EMF of the battery. Got it? Voltmeter is ideal, ammeter is ideal. Therefore, internal resistance of the ammeter is 0. Therefore, voltmeter directly connected to the battery. Therefore, the EMF of the reading of the voltmeter is the EMF of the battery. So here also we can apply the same point, same theory. Look at board here. Voltmeter, this terminal, look at board. This terminal is directly connected to the negative terminal of the battery. The other terminal of the voltmeter connected to the battery through the ammeter, but ammeter is ideal. Ammeter is ideal means the resistance of the ammeter is zero. Resistance of the ammeter is zero. So it means the voltmeter directly connected to the positive terminal and voltmeter is directly connected to the negative terminal of the battery. Thus the voltmeter reading is equal to the EMF of the battery, capital E. Got it? Star point and right. The voltmeter and ammeter are ideal, within brackets perfect. The voltmeter and ammeter are ideal, within brackets perfect, within brackets perfect. We'll stop. The voltmeter is directly connected. The voltmeter is directly connected to the positive and negative terminals of the battery. The voltmeter is directly connected to the positive and negative terminals of the battery. Positive and negative terminals of the battery. Therefore, we'll stop and continue, same point. Therefore, the voltmeter reading is equal to the EMF of the battery, E dot M dot F. Therefore, the voltmeter reading is equal to the EMF of the battery. EMF of the battery. What's the simplest meaning of EMF, dear? Potential difference between positive and negative terminals of a battery. But definition is slightly different. Right? So therefore, you align and write therefore the voltmeter reading. They have said voltmeter reading as V2. This V2 should be equal to the EMF of the battery, that is capital E. So I can write therefore V2 equals capital E. V2 equals capital E. Right? So let me mark this as the third equation. Okay? Next star point. Next star point. The above two capital R resistors. The above two capital TW. The above two capital R resistors are connected in parallel. The above two capital R resistors connected in parallel. You align and write the equation. Therefore, the equivalent resistance equals, look at bold here. How do we find the equivalent resistance here? When two equal resistors are connected in parallel, what is the equivalent resistance here? One resistor divided by 2, or half into one resistor. Half into one resistor, or resistor, one of the resistor divided by 2. R and R equal. When two equal resistors are connected in parallel, equivalent resistance is one of the resistance divided by 2, or half into one resistor. Okay. So one of the resistor is R. So this is R over 2. Complete. Now we can edit this circuit. Now no need to draw two resistors like this. No need. We have found their equivalent resistance. Therefore, draw a new circuit with the equivalent resistance R over 2 ohm. So this is, please don't forget that this is a discussion. Therefore, I'll give all the details related to the question, and I will draw so many figures because I am discussing, I am teaching. Draw this figure here. So now we can directly apply Ohm's law. You see, there is no resistor here. Ammeter is ideal, no resistor is there. So I can directly apply Ohm's law. So if I apply Ohm's law, V equals IR. The potential difference across the resistor is E. Current flows to the resistor. This entire current I2 flows to this because no current flows in the voltmeter. Voltmeter is ideal. It is given in the question that voltmeter is ideal. Therefore, no current flows to the voltmeter. Clear? So therefore, the entire I2 current flows through this equivalent resistor R over 2. So this is I2. The resistance is R over 2. If I use cross multiplication, I can take 2 to this side, r to the other side. Don't write anything. So I get e into 2 divided by r equals I2. So it means, let me write one more step. It means I2 is 2 times E over R. But look at board here. Look at board. What is E over R? Now, what is E over R? E over R is I1. Am I right? So therefore, in the place of E over R, I can write I1 and 2 will also be there. So therefore, it is, look at board. Look at board. So this is 2 times E over R means I1. So this is the fourth equation. According to the fourth equation, I2 is 2 times I1. Yes. So now we have already obtained the answer. Please complete. Now I'll give you the 5 answers. We'll select the correct one. Write them all there. Right now, according to these answers, these things, which current is bigger? I2 is bigger. What about the voltmeter readings there? What about the voltmeter readings? They are equal. V1 and V2 equal. V2 is E. V1 is also E. Right? So let me give you the 5 answers. They have given answers like this. The first answer is given as V2 equal V1 and I2 bigger than I1. Write the 5 answers here. Second answer, V2 equals V1 and I2 smaller than I1. Third answer, V2 bigger than V1 and I2 bigger than I1. Fourth answer, V2 bigger than V1 and sorry, it should be like this. And here it is bigger. Fifth answer, V1 equals V2 and I1 equals I2. And now check the 5 answers. Compare the 5 answers with the things that we have found. Compare them. So it's so simple. According to equations 3 and 2, V1 and V2 equal. According to third equation and second equation, V1, V2 equal. V2 equal V1, V2 equal V1, and V2 equal V1. So it means 1, 2, 5, okay. 3 and 4 not okay. 3 and 4 not okay. According to the equation 4, I2 current is 2 times I1. It means I2 current is bigger. I2 bigger than I1. I2 bigger than I1. V2 equal V1. Therefore, answer is 1. Answer is 1. Right. Check whether you can understand it. But this is not the method used in the exam. Now let me explain how to do this question as an MCQ. Okay, I'll explain how to do this in the examination in MCQ method. Look at board. Right. So this is the first circuit. This is the second circuit. Method is so simple. Ammeter is ideal. Ammeter is ideal. It means no resistances are there. Therefore, voltmeter is directly connected to the positive terminal of the battery. Voltmeter is directly connected to the negative terminal of the battery. Therefore, voltmeter reading is exactly the EMF of the battery. So, according to the first circuit, V1 is E. If you consider the second circuit, voltmeter directly connected to the positive and negative terminal of the battery. There is no resistance because ammeter is ideal, no resistor here. Therefore, the voltmeter reading is the EMF of the battery. Even from the second circuit, voltmeter reading is E. So, from both circuits, we can prove that V1 equals V2. Clear? Now consider this resistance circuit. What is the current in the circuit here? This is R, the voltage is E. What is the current here? If you apply Ohm's law, V equals IR. If you apply V equals IR to the first circuit, right? V equals IR. V is E, R is R, current is I1. V is E, I is I1, current is R. If you take R to this side, you get E over R equals I1. So this is the current in the first circuit. The second circuit, two resistors connected in parallel. Two equal resistors connected in parallel. Therefore, what is the equivalent resistance there? R over 2. Voltage E, current I2. If we apply Ohm's law, V equals IR, V is E, I is I2, current is R over 2. Current is R over 2. Two equal resistors connected in parallel. Then the equivalent resistance is one resistor divided by 2. So if you use cross multiplication like this, you get E times 2 over R equals I2. So it means I2 equals 2 times E over R. What is E over R here? E over R is I1. This is I1. So now, if you compare these two, I1, I2. I2 is 2 times I1. It means I2 is bigger than I1. So actually this is what you want to do in the examination. Actually no need to write any of these things. By just looking at the circuit, you can imagine these things. So answer is 1. Would you write like this as a non? This is what you want to do in the exam. No need to draw circuits, no need to write any descriptions. By just looking at the two circuits, you can get the answer within less than 10 seconds. Write this not. So this is not such a big case. Actually, the current in this circuit should be larger because resistance is smaller. When resistors connected in parallel, equivalent resistance will be smaller. So when the resistance is smaller, current should be larger. Therefore, I2 should definitely be larger than I1. No need to write like this. Here the resistance is R. Here the resistance is R over 2. Lower resistance means larger current. Therefore, I2 is larger than I1. No need to apply also. The 2 voltmeters directly connected to the battery. Therefore, the 2 voltmeters should have the same reading of E. 4 seconds. You just want 4 seconds to answer this question. Okay, dear? Low resistance, larger current. Both voltmeters directly connected to the battery. Therefore, voltmeter reading should be the EMF of the battery. So 2 voltmeters show the same reading, but current in the second circuit is larger. I2 larger than I1, V1 equal V2, less than 4 seconds, you can get the answer. Okay, dear? Right. So I have explained how to solve this problem considering as an essay and how to solve this problem considering as an MCQ. I have given both methods. Right. Now let's try for question number 46. Q46. Right. Q46. A circuit containing 75 ohm resistor and 75 ohm resistor and look at board and look at board and right an unknown resistor in a box within brackets capital B, as shown in the diagram, 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 full stop. The internal resistance of the battery is negligible. 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 Okay, full stop. If the voltage across 75 ohm resistor is 9 volt, if the voltage across 75 ohm resistor is 9 volt, if the voltage across 75 ohm is 9 volt, comma, which of the following represents the unknown resistors if the voltage across 75 ohm is 9 volt, comma, which of the following represents unknown resistors. Draw the circuit here. So we will find the things inside capital D. We just want to find the thing inside capital B. That's it. This is 12 volt. This is 75 ohm. We want to find the things inside the box capital B. They have given the possible combinations, the possible things inside B. We have to select one of them. Draw the circuit here. First answer, they have said things inside the box will be like this. This is the box. We have selected the correct one. Right? They have given us the 5 possible combinations which can be inside this box B. Right? Try here. Try here. Try. Draw the figure and try to identify the things inside the box. Right. Actually, it's nothing there. The only thing that you want to do is look at board. Just name these points as X, Y, Z. You just want to name the points as X, Y, Z. Then you have the answer. You will not believe me, but once you mark X, Y, Z, you have the answer. It is given in the question that VXY 9 volt. It is given in the question that VXY equal 9 volt. Am I right? So what is the total voltage of the circuit? What is the total voltage of the circuit? 12. If VXY 9, what should be VYZ? What should be VYZ? If this is 9, this should be 3, then 9 plus 3 is 12. Right? So that's it. So then, therefore, VYZ should be 3 volt. Am I right? 9 plus 3 is 12. Do you remember voltage divider rule here? According to voltage divider rule, VYZ equals total voltage divided by total resistance into, I want to find the potential difference between Y and Z. Therefore, this should be multiplied by the resistance between Y and Z. What is this here? What is this? What is the name of this theory? Voltage divider rule. Look at voltage. VYZ 3 volt. Total voltage of the circuit is 12. Total resistance of the circuit is 75 plus B. 75 plus RB. Resistance between Y and Z is RB. Am I right here? So if I use cross multiplication, I can take 75 and this things to this side. 3 into 75 plus RB equal 12 times RB. Can you understand this math here? I have used cross multiplication to interchange the terms. Now we can easily divide this 3 and 12. We can easily divide 3 and 12. Then what will happen here? 75 plus RB equals 12 divided by 3 is 4RB. Is the math clear? Now just take this RB to the other side. 75 equals 4RB plus RB goes to the other side as minus RB. Then 75 equals 4 minus 1 is 3 RB. If you take 3 to this side, 75 divided by 3 equals RB. Therefore, resistance between Y and Z, or the resistance inside this box is 75 divided by 3 means 25 ohm. Right? So, among the 5 answers, we have to find the combination which gives 25 ohms. Write them all. Actually, there are many other methods to find RP. This is not the only method. There are some other methods you can use to find RP. Right. So if I want 25, what is the equivalent resistance here? 25 parallel 25 means when two equal resistors connected in parallel, equivalent resistance is 25 divided by 2, 12.5. So this is not the answer. What is the equivalent resistance here? 0. Because this is the wire. Resistance of a wire is 0. 0 parallel with anything is 0. 0 parallel with anything is 0. Most of the students, they don't see this wire. Resistance of a wire is 0 ohm. 0 ohm parallel with 25 ohm is 0. 0 parallel with anything is 0. This is 50. This is 75. 1, 2, 4, 5 incorrect. 50, 50 parallel. What is the equivalent resistance here? When two equal resistors connected in parallel, equivalent is half. 50 divided by 225. Therefore, the answer is the third one. But most of the students, they mark the answer as a second one. They don't say this why. That's the case. Complete. Right now, let's try for question number 47. Question number 47. Right? The diagram shows a resistance within brackets AB. The diagram shows a resistance within brackets AB, comma, an ideal voltmeter and ideal ammeter. Ideal voltmeter and ideal ammeter. Ideal voltmeter and ideal ammeter connected to a voltage source. Connected to a voltage source. Question number 47. The diagram shows the resistance within brackets AB, comma, an ideal voltmeter and ideal ammeter connected to a voltage source. Connected to a voltage source. Connected to a voltage source. Full stop. The voltmeter. Full stop and write. The voltmeter reading within brackets V. The voltmeter reading within brackets V. And the ammeter reading within brackets capital I. Voltmeter reading within brackets V. And the ammeter reading within brackets capital I were taken while the contact capital P, voltmeter reading B and the ammeter reading I were taken while the contact P is sliding along the resistance. The contact P is sliding along the resistance AB from A to B, sliding along the resistance AB from A to B, from A to B, full stop. Which pair of graphs, which pair of graphs would correctly represent the variation of I and B with X? Which pair of graphs would correctly represent the variation of capital I and capital B with X? What is the question? Let me read. Which pair of graphs? They have given two graphs. Which pair of graphs would correctly represent the variation of capital I and capital B with X? You need the figure to identify what the X is. So there is a coil actually. This is the wire wound like this. This is said to be a coil. What is the coil here? You take the wire and you wound it on some insulated tube, something like plastic, right? The point B is here. Point A is here. There is a sliding contact. Let me draw it by using a separate color. This is the ammeter. Sorry, this is the voltmeter. Right? The sliding means something like this. Sliding means sliding means something like this pen made of copper, normally made of copper. So you can move this sliding key, the copper contact from A to B and like this. So they have named this sliding as P, named as P. Draw the figure. The battery voltage is not given, we don't want it. This is ammeter, this is voltmeter. X means this distance is X. This distance is X. Right? So please name this as a coil here. Coil is normally a wire which is wound on a tube. So this is a coil. Let me take resistance of the coil is, let me take it as R ohm. What is the resistance of the coil here? R ohm. Write it. Write them all. Right. Now if I apply, what is the current flows to the voltmeter? They have said voltmeter is ideal. Voltmeter is ideal. And current in the voltmeter 0. Mark it. Voltmeter is ideal, therefore current flows to the voltmeter is 0. Mark it. So now I can easily apply Ohm's law to the coil. And ammeter is also ideal. Ideal means internal resistance 0. So I can apply Ohm's law to the coil. Listen dear, we cannot apply Ohm's law to the coil if the ammeter is not ideal. Ammeter is not ideal means resistance of the ammeter is not 0. Can you understand? If the ammeter is not ideal, it has a resistance. Then we have to apply Kirchhoff's law if the ammeter has a resistance. So when we discuss more past paper questions, we will find questions where the ammeter is not ideal. Here ammeter is ideal. Therefore, we can directly apply Ohm's law to the coil. So if the battery voltage, let me mark the battery voltage as E volt. It's not given. This is not given, but I use the letter E. So E is the voltage across the coil. I is the current in the coil. Resistance is R. If I take R to this side, E over R equals I. Therefore, what is the ammeter reading? Come on. What should be the ammeter reading? Ammeter reading is the current flows through the ammeter. Ammeter reading is the current flows through the ammeter. Current flows through the ammeter is I. This entire I current flows through the circuit like this. You should mark the current also. Wait, you should mark this current also. Ammeter reading is I. I is E over R. I is E over R. So what is your decision here? Is the current constant or not? Wherever this slider be, the entire current flows through the coil. Therefore, the current in the circuit is constant. Got it? Write them all. Start point and write. Both capital E and capital R are constants. 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 Therefore, current in the circuit should be constant. Therefore, current in the circuit should be constant. Within brackets, whatever the value of x, current should be constant according to the above equation. Within brackets, whatever the value of x, the current should be constant, comma, according to the above equation. According to the above equation, whatever the value of x, the current in the circuit should be constant according to the above equation. Close the bracket. So what is the above equation? Current equals E over R. Both E and R are constants. The value of E, the value of R not change with the distance x. What is x here? X is the gap between A and B. X is the distance the contact B from the point A. So whatever, whether you increase or decrease, resistance of the coil R and the battery voltage E remain unchanged. Therefore, current is constant. So what should be the graph of the current here? If this is X, if this is the current I, the current should be constant. That's it. Right. Now, what about the voltmeter reading here? To find the voltmeter reading, actually, listen here. Voltmeter reading is the potential difference between A and B. Voltmeter reading is the potential difference between A and B. Am I right? VAB can be found by Ohm's law. V equals IR. VAB equals I into R is RAB. Resistance between A and B. Actually, even it is wound, it's a wire. Am I right? Even it is wound, it's a wire. Length of the wire can be taken as X, OL. So, this is I. Resistance of a wire is given by rho L over A. Length divided by cross section area. We have already found that current is a constant. So I don't worry about current. Rho is a constant. I don't worry about rho. Cross section area of the wire is a constant. I, rho, A, all the things are constants. Only the length is changed. So then I can write this as this is VAB equals KL. Length of the wire. Length of the wire in between A and B is increased when X is increased. X is larger mean length of the wire in between A and B larger. X is smaller. X is smaller mean you can keep the contactor here. How do you reduce length? Just keep the contact B here. Then X is smaller. How do you increase X? Keep the contactor here. And now X is large. When X is increased, B comes here. Like that. Okay? So by increasing X, you can increase the length L. By decreasing L, you can decrease the length L. Therefore, VAB will be larger when X is large. VAB will be smaller when X is small. Got it? Right there. Star point and right. Star point and right. Simple L. Star point and right. Simple L is the length of the wire in between A and B. Simple L. You can put that right. Simple L is the length of the wire in between A and B. Simple. L is the length of the wire in between A and B. Full stop. When the x is increased, you can go there, write x. When the x is increased, when the x is increased, when the x is increased, comma, the length L is also increased. When the length, when x is increased, when x is increased, the length L is also increased. Full stop and write. According to the above equation, according to the above equation, according to the above equation, comma, the voltmeter reading, according to the above equation, the voltmeter reading within brackets VAB, according to the above equation, the voltmeter reading within brackets VAB is increased when L is increased. When L is increased, according to the above equation, within brackets VAB is increased when L is increased. You will line and write. Therefore, the variation of the voltmeter reading with X. Therefore, the voltmeter reading with X will be changed as shown in the following graph. Therefore, the voltmeter reading is changed with X as shown in the following graph. Therefore, the voltmeter reading is changed with X as shown in the following graph. Lovely, here please write. I forgot to write one more thing. Just put comma and write K equals I rho over A. This is the constant. So as this is as K is a constant, when you increase L, VAB increase. VAB is the voltmeter reading. So voltmeter reading increases when L increases. L is increased when X is increased. Therefore, when X increases, L increases and voltmeter reading increases. So what should be the graph then? Variation of the voltmeter reading with X. So this is V is voltmeter reading. So when you increase X, voltmeter reading is also increased. What is the shape of this graph here? What is this graph here? What's the equation that we have obtained? We have obtained VAB equal K. So the graph is in the shape of Y equals mx. So it should be a straight line like this. That's it. Complete. Right. So what is the answer here? The correct answer according to the given five answers, answer is 1. They have given five answers. The first answer is given like this. This is x, this is I, and here this is x, this is v. I is a straight line, v is also straight line, but current is constant. Voltage increases when the length is increased. So this is the answer for the question number 47 is 1, 2001 AL MCQ paper. Question 47, answer is 1. Some students ask, what is the point P? It's a variable point. P is the point where this contact touches the coil. Right? The contact is named as P. It touches the coil at the point B. Therefore, when the contact touches the coil at different places, B will be changed. Can you understand? B is the point where the contact B touches the coil. So when you change the position of the conductor, the point B is also changed. Got it? That's it. Because now we can write B is the point. B is the point at which the B is the point at which the contact B touches the coil. B is the point, comma, at which the contact B touches the coil. B, capital B, B for ball. B is the point and on the coil at which the contact B touches the coil. Right. That's it.